We take turns making notes. So I didn't make this unit, but I still will use them happily. Okay. So, example, here, we're going to get some room here. Okay. So let's see this example. Go ahead and write this here, and we'll do another one. Oh, and this one will not have A is 1. 3. Okay, what are the factors of my constant? So right now I'm looking for my possible roots. Positive and negative 1. That's the factors of my constant, right? And then I'm going to divide those by the factors of my leading coefficient. What is my leading coefficient? 3. What are its factors? 1 and 3. You guys with me? So I need to divide these. So I'm going to take the 1 over 1. Right? And then the 1 over 3. So the positive and negative factors of the constant, that's where I got the 1 from, right? And then the positive or negative factors of the constant over the leading coefficient. We doing okay? Yeah, read.
I'm confused on what the first x dot 8 means.
X dot 8.
Like before the f(x)?
Oh, example 8?
Oh, example 8.
Yeah. Okay. Other question, yeah.
Okay, why is 5 not up there?
Because 5 is not the leading coefficient or the constant. Leading coefficient means the one with the biggest exponent, and the constant is the one with no variables, no letters, only numbers, right? So the middle ones don't give us any good factors. They only are there when I do my division. Does that make sense? Okay, let's finish this one out. I want to try 1/3, okay? I want to try 1/3. Why? Because you need the practice of making the factor that goes with 1/3 as a root. Okay? So if I'm trying 1/3, make that factor. Careful. Be careful. Make that factor. This is the root. What's the factor that goes with it? There should not be a fraction in its factor. Careful. There should not be a fraction in its factor. That's your hint. Okay, I'm going to give you guys some time, and then I want someone I haven't heard from yet today to answer. Not Drake or Reed.
I haven't answered.
Landon.
3x plus 1.
So close. -1. Sure. I know that when I took this factor and set it equal to 0, I have to get 1/3, right? So I know it has to be the opposite sign, but the way I get the divided by 3 is for having the 3 times the x. Does that make sense? Okay? Yeah.
So does it always work to use the denominator x?
Yep. And one way you can see if you've done it right is by putting the 1/3 in and then seeing if you get 0 in your factor. Does that make sense? Yeah. Another question? Yeah, Early.
Okay, so if you did negative 1/3 instead of positive 1/3, would it change it to 3x plus 1?
You got it. Okay, take a second and divide that factor. This is just another example of the root factor thing that Arilee was saying. So I want you to try this one. Take a second and divide that factor using what we did last time in. Okay? Oh, yeah. What's up? Yeah. Go ahead.
Because you said, let's see, the biggest exponent.
Not the biggest exponent, the number in front of the leading exponent.
Yeah, that's what.
Okay.
Where you get one. Or
So
do you drag it down?
it's the factors of this. So this is prime, so its only factors are 1 in itself.
Okay.
And this one, because it's 1 and prime, it only has the factor of 1.
So what happens if I have like 9?
Then I would have to do 1 over 1, 1 over 3, and 1 over 9.
Okay.
Good. Quinn, we're on the next page. It works! Da 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 da! Hooray! Yes, Sasha.
So if we use the other, so we use the 1/3. If we use the 1 instead, would it still work?
1 would not have worked, but -1 as a root would have worked. Careful, because if you tried x plus 1, that's the other one that works, but that's the factor. So you have to be careful about the roots and the factors going back and forth, right? Now hold on. The whole point of today is to take what we've been learning and apply it to factoring completely, right? So when I factor this completely, do I go back to the original, like the 147? Or do I use the 21? It's not actually 21, right? But that's what I'm saying, right? I don't go back to the x cubed and try more possibilities. Now I factor my quotient here. Does that make sense? You guys with me?
Yeah.
So factor that. Okay, that's what I got. Is that too fast?
No.
So then if I want f of x, so this is f of x in standard form, right? If I want it in factored or intercept form, I would say f of x is 3x minus 1 times x plus 1 squared, right? And then if I wanted to list all of its roots, because it depends on what it asks on your homework, I would say 1/3 and -1 multiplicity 2. Is that making sense from what we've been doing?
Yeah.
We're putting it all together, making our connections.
Oh, actually, why is it -1? Never mind.
Okay, answer that question for everyone though, because I'm sure you're not the only one who had it.
Because if it's x plus 1, then it would be -1.
The root would be -1 then, right? And why is it m2?
Because it's twice.
Because there's 2 of them. Nailing it. You guys ready to try one start to finish? Yeah, you are. I'm feeling it. Okay? I'm feeling it. Okay, well, I might help you get a little bit started here, because I'm going to give you one that's a little weird, because I know you can handle it. Yes. Okay, example 9.
I took the entire page too.
Sorry.
Are we going to do example 7?
I'll probably just talk about it. Because I went over one exactly like number 7 on the homework.
All right.
Okay, take a second, write that down, and then I want you to tell me why this one's weird. Why is this one weird?
Because
There's no constant, right?
it'd just be 0.
It is 0. But careful. What has Miss Summers been trying to drill in your brain since your first day in here to do? Besides your homework.
Jason.
Yes, GCF. Pull out the greatest common factor. What is it on this one? Yes.
Oh, right.
So X, take that out.
Oh, now we have.
Now I have a constant and a leading coefficient,
Whoa.
right? So the factors of my constant are 1 and 2. And then the factors of my leading coefficient are 1 and 2. So let's make a list of my possible roots. I do 1 over 1. What does that become? Good. 1 over 2. 1/2. Then 2 over 1. And 2 over 2. That doesn't add anything new to my list, right? Does that make sense? Okay, the one I want you to try first is -1/2 because I want to practice writing its factor. Okay, so if I'm going to try -1/2, there's no rhyme or reason to what you try first, okay? I just want us to practice writing this factor. So write the factor out. Take a second on your own, write its factor that goes with -1/2. All right, I got 2x plus 1. Why +1? Because my root's negative and the root makes the factor 0. Raise your hand if you got the 2x plus 1. Anybody get it? Oh my goodness. Okay. Hey, do I divide the original? Oh, by the way, I lied to you at the beginning of class. Guess how much homework time my B6 class actually had? None. And you guys are looking at 10, 15 minutes. You guys are doing great.
So we
See?
don't need to see each other.
That would be the opposite of the lesson I think we learned from today. Okay. So here, let's go. What was I asking? I lost my train of thought. Oh, do I divide into the original or the one after I've taken out my GCF? After, because once I divide something out, I start splitting the smaller thing down, right? Okay, so we're gonna divide into the cubic. So 2x plus 1
Wait, so will the roots always work? Or
No, I just told you which ones to try because I wanted to practice.
always got
Yeah. So once you pick one to try, you might get a remainder of something. If it's not 0, then you go to the next one. Just like if I try in numbers, if I try to divide by 2 and I get a decimal, I go to the next one, right?
So you're taking the one like from the one with the GCF that's out, right?
Yep, right here.
Take that one.
Because once I divided the x out, you want to make sure you never go back to the original. You do the smaller thing. Guys, make sure you're trying this on your own. Okay, it worked because I got a remainder of 0. So then, now I have it down to a quadratic quotient, right? So factor the quadratic quotient, the x squared plus 3x plus 2. Yes, the GCF goes out front. Good. All four factors should be represented in my factored form. That was a great question. Who asked it? I want to know. Good. What I have on my paper right now is not done though, right? That's just the first two factors. You guys are going to find the last two for me by factoring your x squared plus 3x plus 2. I've done too much math today, so I can't do it anymore.
So then what's our next step? Just find out
Factor the quadratic quotient.
by doing what adds to
3 and multiplies to 2, because it's a quadratic now, right?
yeah.
Anybody get it? Yeah. I'll do Abby. I've heard from Ashley. Yeah.
F of x equals x, parentheses 2x plus 1,
Good.
parentheses x plus 1, and then x plus 2.
Does it matter what order I put those parentheses in? No, as long as all four are represented, right? So this was my list of possible rational roots, right? Now I want to make a list of the ones that are actually roots. So yeah, Drake?
Is it 0, negative 1/2, negative 1, negative 2?
Nailed it. Let's pause here. Does that make sense? Any questions? Read.
How did you get the actual roots?
It's the zeros of the factors.
Oh,
What else? Anyone in the back? Are we doing okay?
Wait, I actually have a question.
Yeah.
How do you know if it's a negative or a positive? Because the zeros of the roots are plus or minus.
No, the possible zeros of the roots are plus or minus.
Oh,
When I went through and factored them, these are the actual factors, right? So then I take the zeros of the actual factored form.
okay.
Good? Okay, let's just go up and talk about number 7. You guys have done so good today. I'm not going to make us go through it, okay? But it's really similar to the one like I went over on the homework, right? The only difference is I didn't give you one of the pieces. And on the other one, I gave you one of the pieces, right? So I want you to come up with a list of numbers I should try. What do I mean by that?
Oh, well, it's back.
Greatest common factor.
Nope.
Is that the 3, 5, and 1?
Nope.
So how you factor the next number?
It's where I factor the last number and then factor the first number, the rational root theorem.
Or
Right.
you do the factor of the constant divided by...
The factors of the leading coefficient. Yep. 64 has an annoyingly large amount of factors, but you'll be fine because I'm not going to make you try them all. We're just going to come up with the list, right? So I'm going to try plus or minus 1 over plus or minus 1, 2, 4, 8. This is annoying. 16. Good. I was hoping someone would say that 4 divided by 64 for me. 32 and 64. So just for the practice, if I was going to try, I don't know, what do you want to try? 1/8 maybe? 1/64th? Done. If I want to try 1/64th, what factor would go with that? I'm not going to make you do it, but what factor would go with it? Good job. That's the factor I would try. Hey, how do you find the volume of a cube? Length, width, height, right? So that's my just hint, because I think there's another one of these on your homework tonight, that you're just trying to get it down to your 3 parentheses. So it's just like what we've done today. And what you did last time is just instead of me giving you a factor, now you know how to find the factors to try, right? Instead of just having to randomly try numbers. Do you guys understand? Last chance for questions. Okay, I'm going to give you 13 minutes of homework time. That's it for today. Great work. Okay.